the last talk of the day, the last talk of the conference. Please welcome Michael Hyatt from Elastic, talking about what may be one of the most important APIs to emerge in the last couple of years, OpenTelemetry. Take it away, Michael.
Thanks, Rob. Hi, everyone. Michael Hyatt from Elastic. I'm a solutions architect, been with Elastic for 4 years. Today, my talk is going to cover a lot about OpenTelemetry, a little bit about Elastic, right? Anyone here familiar with OpenTelemetry? Great. Okay, anyone here attended the workshop yesterday about OpenTelemetry? Well done. You'll find this basically an extension of that workshop. I made sure we don't have a lot of overlap, but if you didn't attend it, don't worry about it. I'll answer your questions. We'll cover enough ground for you to be across what it is and does. You heard of Elastic, obviously? Show of hands. Yeah, thank you. Yeah, it's quite a popular company. And Stable Diffusion. Anyone? Yes, it's not a Solana app. Okay, all right. So you're in for a treat. Hang on to it. All right, so let's get started. So this famous tweet from 2015. So microservices, they definitely made a life easier for developers, but life and support was made so much harder because of these distributed apps. It's a very old tweet. Still, things are still hard. I don't think we've made any progress in the 7 years since we had this tweet, mainly because it's just distributed systems, right? It's hard to observe and understand what's going on. You know, it kind of represents the life of the SRE, like when you only have logs and metrics and your customer is calling you and saying, hey, your app is slow or throwing an error, and then you start looking at logs and metrics and trying to correlate them and, you know, correlation and causality and explain something because of this correlated. And it reminds them, you know, it's like how you solve a murder mystery, right? A lot of circumstantial evidence, hopefully, mean causality, not a correlation, right? Observability, right, is supposed to fix this. Observability for us means two things. So two things. First thing is the discipline of deducing the complicated state of internal system based on its external outputs. Like we're looking at the system from outside in, and hopefully we'll be able to make sense what it is, what it does, what's happening, what happened at a certain time. And then observability also means a collection of tools we use to understand what is happening in system at a certain point in time, right? So it's both the discipline and the tool set. So when we're going to be using the term observability, or you hear me say observability, it may mean two things. So you'll have to work out based on context. Nothing, well, I should have, like, I'm doing the last, basically, talk for the day, so, like, I have to keep you on your toes and, like, you know, this famous quote from Leo Tolstoy, right, about all the happy families look alike, but all unhappy families have their own observability problems, right? So there's too many tools. There's like, oh, I can't leave my logging vendor from 2012, and you know, the data observability data I sent to the cloud is not mine anymore. It's there. I cannot get it back to analyze. It's gone. I had to build my own tools because the vendor didn't supply the tools, and you know, I'm not allowed to log debug messages. I think it's day in life. Like a lot of you are familiar with it, and this is a lot of the industry have to live through that over and over again. Now, mind you, every organization, every company, and every team have their own problems. They're different in how unhappy they are with the state of observability, right? But there's a lot of common themes. Now, OpenTelemetry is not going to solve it for you. That's the bad news. It's going to make things better, but there's still, and it's going to enable a few things that may help you improve things and bring you back into the sort of the happy place. It's not going to magically solve broken observability, but it makes a very important step forward. It gives you one important capability. It makes it easier to fix broken observability, for example, by leaving your existing observability vendor that doesn't suit you anymore, right? It allows you to send observability data to more than one backend. So you can transition from one observability vendor to the other. You can augment an observability vendor by another observability vendor. You can change the monitoring provider, the instrumentation without the monitoring backend without re-instrumenting your application. So you instrument it once, and then you can change the backends. You can build your own observability without changing your application, which is important. This is the first step of, fixing broken observability, in my opinion. Collection agents are decoupled from the backend. And basically, we see as a vendor that our customers, we're an observability vendor. For our customers, OpenTelemetry becomes like, this is the must-have. You have to be able to basically live and consume observability data as observability customer, as observability vendor. So what is the target state? Let's say OpenTelemetry succeeds, it is pretty successful, but let's see what happens if it succeeds to deliver on its promise. For the customer, right? So imagine you only have to instrument your application once, and you don't have to change it ever again. You can swap the backend vendors, you can bring additional vendors, you can have your data sent to different sort of monitoring systems, but you don't need to re-instrument your application. You instrument it once, you'll need to update the agents because there'll be like new updates, but it's different from having to re-instrument your application. So you don't have to worry about picking the best observability solution for your application day one, right? So you can actually leave the decision point, and you can change your mind, right? It's all about flexibility. For the vendor, it's actually very exciting because it levels the playing field and allows to create a competition. And for me, it's actually more exciting because we'll have to run faster. So we'll have to be more innovative, and we'll have to build the backend of choice for OpenTelemetry. So really looking forward to it. Observability tool market, so O11Y. It's probably K8S, you guessed, it means observability. So for the observability tool market, you'll be able to, select additional vendors. You'll be able to change observability vendors. You wouldn't have to the cost of making a mistake on day one, selecting your observability platform is kind of becomes negligible. Let's look at, another view on OpenTelemetry, what it actually defines. So if we look at the traditional telemetry collection sort of landscape, right, we're talking about mainly observability, sort of means, logs, metrics, APM. It's much more than that, but the vendors like to call it 3 pillars of observability. There's more than these 3 sort of types of data, but we sort of focusing on the main 3. It's logs, metrics, and traces. So logging typically will either get pushed into your monitoring system through something like syslog. So appliances may do that. They push data because you cannot install an agent on your hardware appliance, hardware firewall router. So they use syslog to push the data out. You'll have application data or operating system logs that will be written to a local store. Then they can be picked up from a local store and sent to a collection point. There'll be tracing, so distributed tracing. Show of hands, who knows what distributed tracing is? Application, great, okay. So traces, so application performance monitoring and distributed tracing generate trace data. Trace data using an agent traditionally sent to the tracing backend. In this case, Jaeger, you know the vendors, right? So the observability vendor. And there'll be metrics, right? Prometheus is quite popular, but there'll be others. And as a result, you end up with 3 different collection mechanisms and 3 basically disjointed sort of agent libraries. So you're already kind of getting in a situation where you need to install 3 different agents, and the industry coined a very interesting term called agent fatigue. So you leave a server running in your data center for a while, and you come back to it after 2, 3, 5 years, and it's just full of barnacles and agents and antivirus software that's running on it. So it's called agent fatigue because every vendor wants you to run it and update it and keep it up to date and connect and configure and reconfigure, and it just becomes a nightmare. So already we want to fix the situation where we have to put 3 different agents into our application to be able to get our observability data. So OpenTelemetry is really about fixing the collection part of observability, and it's a collection of libraries, SDKs, APIs, and components that basically allow you to sort of clean up this space, clean up the data collection space. So OpenTelemetry doesn't get into the backend. It doesn't define how you should store the data, where it should go. It only defines the collection and transport of the data, how it's being sent to the backend. Okay? So it's a collection of APIs, tools, and SDKs. Now, what's the nirvana? What is the OpenTelemetry target state? What does it look like? It looks like you should be installing 1 agent, right? And then you're sending the telemetry. because you're sending not just logs, metrics, and traces. You want to send other types of data like synthetic monitoring, uptime monitoring, real user monitoring, profiling data, you name it, right? There'll be more data, security-related events. You want to send them all as your observability stream, right? So and then you want to have, and there is also a component called collector. So collector, think of it as, it's like pipes and filters for telemetry data. So you receive it through an input, it supports multiple inputs, it puts it through a series of filters, transforms the data, enriches the data, filters the data, and it can push it out to different outputs. It's like an ETL, extract, transform, and load for observability, right? So it doesn't deal with the backend. So these are the kind of the boundaries, the delineation of the focus areas for OpenTelemetry. Doesn't get into the backend, right? The backends, you can do whatever you want. It basically focuses on collection. It focuses on basically transforming the data, aggregating, collecting the data, and then it pushes it out to the backend. Now, let's look at some of the architectures, right, that OpenTelemetry allows or implements. So you don't need the collector. Your agents, if they support OpenTelemetry protocol, they can talk directly to the backend. So your backend, if it supports OTLP, right, it's OTLP, OpenTelemetry, OpenTelemetry protocol, L, there's L. They should be able to talk directly to your backend. You can also, for some reason it's doing 2 clicks. All right, so it's doing one page before. So you can use the collector and you can mix your observability data you can mix your OpenTelemetry data with other types of data, right? So you can bring an additional, so OpenTelemetry collector understands other protocols, not just OpenTelemetry. And you can basically normalize the data and you can sort of filter, enrich. It basically becomes like a focus point, like an integration point for OpenTelemetry data, again, before it's sent to the backend. Lastly, you can chain OpenTelemetry collector. Chaining OpenTelemetry collector allows you to create sort of messaging sort of like, you can put a messaging bus between the two OpenTelemetry collectors, and then, for example, plug in Jupyter notebooks with Kafka client and start doing data science on your OpenTelemetry data if you feel like it, right? So the possibilities are endless. Right, Stable Diffusion, promised you. So text-to-image networks, had a lot of fun running it on my laptop, and this for me represents the art of the possible, right? So if you didn't know that, Stable Diffusion is a way of turning a text prompt into an image. You probably heard of DALL-E. So Stable Diffusion is the open source equivalent of it. So for me, so what is the art of the possible? What was I able to discover when I started looking at OpenTelemetry? And actually that says, wow, that's new. Haven't been able to do that before with the traditional observability tools. First and foremost, right, so there's a link to a how-to and a blog post that describes how you can mix and match Elastic APM agents and create a distributed tracing between OpenTelemetry and Elastic agents. So I've got a Node.js Elastic agent calling an API gateway and tracing 2 lambdas, between the 2 lambdas, basically generating a trace, okay? If you're interested, you're more than welcome to check out the blog post. Mixing the two, right? AWS have it's called ADOT, is Amazon distribution of OpenTelemetry, and it supports Lambda tracing, and actually having standards and distributed tracing allowed basically stitching a distributed trace and sending it into Elastic. So if you're curious, if you want to start tracing, your application involves Lambdas and sort of other technologies, mixed technologies, you can definitely follow that link. And the resulting, I was able to load Kibana with the APM view and see 2 agents talking to each other. So I created an animation because I think the screen situation is a bit messed up, so I'm not going to try and change tabs. But it's actually, well, it was pretty amazing, like 2 different technologies, sending telemetry data and working in sort of in conjunction with each other. One other exciting experiment, right? I was watching a company called Pixie Labs. And Pixie Labs, they basically use eBPF to instrument Kubernetes. They allow you to inject profiling and monitoring points into your Kubernetes cluster, arbitrary profiling points, and say, you know, start tracing sort of DNS queries, for example, coming out of your Kubernetes cluster. And they allow sort of inserting temporal, so you can temporarily insert a probe point, look at the data, maybe remove the probe point. But what if you want to leave it? What if you want to leave it to run it there for a long time and look at the data and create basically another data collection point? You want to look, basically just leave this collection point and send the data to OpenTelemetry backend. Pixie Labs supports OpenTelemetry collector. So you can actually plug in an you can send the telemetry data to an OpenTelemetry collector destination. And this OpenTelemetry destination can forward your telemetry data to your backend, right? The backend that supports OpenTelemetry. Again, we're seeing multiple vendors starting to live in an ecosystem rather than every vendor trying to lock you into their little walled garden. We're seeing multiple vendors having to interoperate and work together, obviously benefiting the end users, hopefully. So that's exciting. Pixie Labs, they were acquired by New Relic. They were open source, so New Relic open sourced them, and they basically donated them to CNCF. So they're one of the CNCF projects now. So one other experiment, which was pretty much, I think, you had to really have your vendor, right, you had to give your vendor give you a tool. So track and trace of message event fabrics. Think Solana or Kafka, right? Where do my messages go? How do I track the flow of messages? Has this message been delivered? How much time did it take for this message to travel from the sender to from publisher to subscribers, to all the subscribers? How many subscribers did it have? Was it a durable subscription or a non-durable subscription? Right, it wasn't possible. You had to have your vendor actually give you a tool to do that. So with OpenTelemetry, you can simply instrument the publishers, mix and match the publishers, and send the data to the right backend. So if your current backend doesn't support it, you want to build your own backend based on OpenTelemetry data, you can do that. So it's a pretty cool use case, and I think everyone's sort of thought about doing it, but I don't think it was possible to do it sort of on any messaging system, in my opinion. Okay. Cool use cases. How can you get your hands on these use cases? And this is the bit about Elastic. So Elastic fully is well, if you don't know it yet, so it stands for, well, you probably know it as ELK stack. So it stands for Elasticsearch, Logstash, and Kibana. Elastic understands OpenTelemetry natively, so it's one of the ways of sending OpenTelemetry. It basically can receive OpenTelemetry data, and it normalizes the OpenTelemetry data into sort of a common schema that allows you to correlate sort of between metrics, logs, sort of other types of observability data. I sort of like to call Elastic as a data platform for observability. Right? So observability is not so much a tool, but it's data platform. So you'll always find a new use case for the observability data that's uniquely to you, right? Because everyone wants to be, we don't want to be unhappy in our own way, so we need to kind of find our own way out of our observability unhappiness. So being able to treat data being able to treat your observability as a data platform is actually quite important to be able to meet your requirements. So Elastic Stack, and if you want to get your hands on Elastic Stack, I provided a link to GitHub repo that allows you to run basically the stack in Docker Compose. So it's my GitHub repo. You can sort of do Docker Compose up and get the full Elastic Stack up and running on your laptop, wherever you have Docker Compose. I think the benefit, the benefit of using Elastic for hotel is basically being able to run it locally. You don't need to drag the cloud wherever you go. You can run it in your laptop, you can run it in the cloud, you can run it in Kubernetes. So your observability backend can follow you. That's pretty much on time, I think. Hopefully. Any questions? Yes?
Would you consider OpenTelemetry ready now for production deployment?
Great question. So OpenTelemetry is being sort of governed and designed by a committee, and they sort of working on sort of in 3 different streams, so 3 separate streams. So traces, metrics, and logs. Traces is ready to go, it's GA, stable. Metrics is ready to go, it's GA stable. Logs are, I think the API is stable. It's still being sort of worked on. It's I think, advanced beta. I would say if you're using a popular framework like you're in .NET or using .NET or Java, yes, OpenTelemetry is ready to go. Python, pretty much ready to go. And ready to go meaning it can auto-instrument. So you can drop the agent and it'll find, say, 80 to 90% of the stuff that's relevant, right? Like your database calls, your HTTP client calls, your HTTP like servlets, and right? So you don't have to do a lot of auto-instrumentation manually. What I'm saying, so some of the clients that are sort of less mature, such as Rust, you'll find that you'll need to do a bit of manual instrumentation, but some mainstream languages are sort of tracing is in good shape, metrics is in good shape, logging is rapidly sort of maturing. I would say it's definitely worth considering it as probably the first choice, or at least as a main way to augment your existing observability vendor instrumentation. Yeah. Any more questions? Yep.
A question about the instrumentation.
Mm-hmm.
So is it, you said pretty much it's set once and then just basically the collectors kind of do a lot of the work.
Yeah.
Does that, I guess if there's more data that you're looking for as you're going forward, is it necessary to potentially have to augment the instrumentation as you're going along? Or
Mm-hmm.
is it something that's just set once and then you've pretty much got all the data there?
I think there's sort of like, you will probably always have to configure things, like you want to get additional metrics, you want to instrument additional things, you'll probably have to change configuration and add API calls and configure the agent and update it. So that's not going away. What's going away is having to completely rip out one library and plug in the other one. So having to rebuild and code to a different API and create different configuration and live with completely different sort of paradigm in terms of instrumentation. So that's going away, and that's what's basically, I think, is kind of hard. Yeah. Yeah. I think software needs sort of care and feed. You need to care and feed for the software, so otherwise it dies. Yeah. Good stuff. Thank you.